Hey everyone, this is question number 10 from chapter 6. This question is about a piano sliding down an incline and a man pushing back on it so it has a constant speed and there's no acceleration down the incline. So first step in all physics problems when you're dealing with forces is draw a free body diagram. You have the weight, the normal force, the force of the man pushing up the block, and it's always easier on inclines to set your axes so that the x-axis goes along the incline. So we're going to start this first part with using Newton's second law. The first part of the question asks us to solve for the force exerted by the man. So we can see that this force of the push is in the x direction, so we can start by summing forces in the x direction. Now, the force of the man is opposite what we have assigned as the plus x direction, so that's going to be minus Fp. And then the only other force we have acting here in the x direction is the x component of gravity. In order to find that, you can look here. This is going to be the same as theta. This x component sine opposite over hypotenuse, so that's going to be sine, and the force of that is just going to be the force of the piano, which is mg sine theta. And there's no acceleration, so this whole thing is going to be equal to 0. We can, in order to solve this, we can add force of the push, force of the man over to the other side. So we're going to have Fp equals mg sine theta. Okay, and then all you have to do is plug in numbers here. Mass of the piano, 380 kilograms, times gravity, 9.8 meters per second squared, times sine theta, which we have over here. The incline is 25 degrees, sine 25. Plug that into a calculator, you're going to get 1,574 newtons. And then with sig figs, that's going to be 1,600 newtons. Okay, so that's part A. Part B asks us to find the work done on the piano by the man. So we have the force. All we need now, we know that force or work equals force times distance. All we need now is the distance. And the thing about this distance, we know it slips down 2.9 meters, so we have that distance. But what we need to notice here is that the man is pushing up and the direction of motion is down the incline. So this work is going to be negative because he's pushing in the opposite direction of motion. So your work equation is going to be work equals FD, like we said, opposite direction, so it's going to be negative. So it's cosine 180, which we know to be -1. Plug everything in here. Work equals force, 1,574 newtons. Distance, we're given 2.9 meters. And then that's all going to be times -1. Plug that into your calculator and you will get minus 4,565 joules. With sig figs, that's going to be minus 4,600 joules. Okay, so the next part asks for the work done on the piano by the force of gravity. So in order to do that, we know the force of gravity So the direction of motion is in the x direction. Gravity is working in that same direction as well. So the force of gravity is going to equal force times distance. Our original angle was 25 degrees. Subtract that from 90, you're going to get gravity is acting cosine 65. And the only force that you have here is the only thing gravity's pulling is the piano, so you're just going to have mg d, because what's work, that's distance, cosine 65. Plug all that in, 380 kilograms. Gravity, 9.8 meters per second squared. Distance, 2.9 meters. Gravity is acting in the same direction as motion, so it is going to be positive, cosine 65. Plug all that into a calculator. You're going to get 4,564 newtons. With sig figs, that's going to be 4,600 newtons. I'm sorry, 4,600 joules because we're doing work. This isn't force. So that's the answer to C. Our final part asks what the net work is on the piano. Because there's no acceleration, the net work is going to be equal to 0. And the only two works that we have here are the work of the push of the man plus the work of gravity. And if you notice in the past two steps, we've gotten that those are equal to each other. So the work of the man is minus 4,600 joules. And the work of gravity is positive 4,600 joules. And there you go. W net equals 0 joules.